Hi guys again. Now we're talking about a mass spring system in physics. Remember we were talking about simple harmonic motion, and the last topic that we saw was about simple pendulum. Now remember, a mass spring system is a spring with a mass at the end. Now let's see. We have I'm gonna read the problem, the first problem. Here is the main equation, and here are the isolations for mass or spring constant in case you need it. Now let's read the problem. The body of a 1,275 kilogram car is supported on a frame by 4 springs. Interesting. So we're talking about 4 springs. 2 people riding in the car have a combined mass of 153 kilograms. So that means inside a car we have 2 people. So we have a combined mass of the car plus the 2 people. So here, these 2 masses are going to be added. You'll see why. When driving over a pothole in the road, the frame vibrates with a period of 0.84 seconds. For the first few seconds, the vibration approximates simple harmonic motion. Find the spring constant of a single spring. The spring constant of a single spring. So that means that we're not going to focus on the 4 springs that we're talking about. So if we need just one single spring, that means that we should divide all the mass by the 4 springs that are acting in the car. Now let's see. To calculate the spring constant, we need the mass and the period. And we have the masses and we have the period. So let's write the givens here. Given mass 1, that is the car mass, 1,275 kilograms. The mass of the 2 people we're going to consider to be 153 kilograms. Now the total mass is going to be the addition of both. So I say 1,275 kilograms plus 153 kilogram. This gives me, let's see, the calculator, 1,428 kilogram. The total mass. This is the total mass. And remember, all this mass is supported by 4 springs. So I want to know how much mass is one spring going to support. So what I do is I divide all the masses that I have by 4, because we have 4 springs. So my answer is 357 kilograms. That means that one spring holds 357 kilograms. This is the mass that we're going to consider for our problem. Now, the period is 0.84 seconds, and I need to find the spring constant. K is gonna be unknown. So according to the formulas, K is mass divided by period over 2 pi raised to the 2nd power. Let's just plug in the givens, and we have 357 kilograms divided by 0.84 seconds divided by 2 pi to the 2nd power. So let's see. 0.84 divided by 2 divided by pi, I raise it to the 2nd power, and 357 divided by my answer gives me 19,974.2. Now remember, the units for the spring constant are Newton over meter. There you go. This is my answer for my constant. Now again, let's review the exercise. I have a car. In that car inside I have two people. So the four springs are not just supporting the car's mass, but also the two people that are in it. Okay? So the total mass that is supported by the four springs is 1,428. But I just need to know the spring constant of one single spring. So what I do is I divide by 4 to know how much mass one spring is supporting. From here, I apply the equation to get the spring constant. And voila. Now, how do I do this? First, I solve the parentheses and then I raise it to the second power. Then I divide my mass by the answer that I got here. And voila, that's the answer. Check. Now, let's see another example. We're talking about the same car, but now it says when two more people get into the car described in the problem before. Okay, let's just see it. When two more people get into the car, the total mass of all four occupants of the car becomes 255 kilograms. Now, this is the mass of the four people in the car. And the car's mass is, from the exercise before, I get it. That is mass 1, that is the car's mass, 1,275 kilograms. And mass 2 of the four people is 255 kilograms. Now let's continue. It says, now, what is the period of vibration of the car when it is driving over a pothole in the road? Now they're asking me to find the period. But as we are talking about the same car and the same four springs, we're talking about the same material, the same kind of spring. So from the exercise before, I got that my spring constant was 19,974.2 Newton over meter. So this exercise is linked with the exercise that I saw before. So I take these two givens that I need here. Now, if I'm looking for the period, I will use the main equation. Okay? But we're talking about the same four springs, so I need to know how much mass is one spring supporting. Now in this case, I have a total mass of 1,275 plus 255 kilograms. My total mass is 1,530 kilograms. We divide by the four springs that we have. Now each spring it's holding 382.5 kilograms. One single spring. Now this is the mass that we're going to use. Now the equation to find period is 2 pi square root mass over the spring constant. Now let's just plug in the givens because we have everything we need. times 2 times 5. Now my period is 0.8695 seconds. And voila, that's it. Now we have one more example right here. It says 1 kilogram mass attached to the end of a spring completes one oscillation or one cycle every 2 seconds. So one oscillation every 2 seconds. Find the spring constant. Now let's take a look. They are giving me mass equals 1 kilogram, and take a look. It says one oscillation every 2 seconds. Now this is what we know as frequency. Frequency is number of time per second. So this is frequency. Remember, definition of frequency is number of cycles per time. So if I want to know the period, I know it's 1 over frequency. This is how I get the period. Now let's see. Frequency is 1 over 2 seconds. So the frequency is 0.5 1 over second. That's how you write a frequency, or 0.5 hertz. How do you get the period? 1 over the frequency. 1 over the frequency, that is 0.5 hertz. This will give you 2 seconds. Now we have the period, we have the mass. Now we're looking for the spring constant. Solution. We say a spring constant is mass divided by period over 2 pi to the second power. My mass, that is 1 kilogram, divided by 2 seconds over 2 pi to the second power. Spring constant is equal to, let's see, 2 divided by 2 pi to the second power, 1 divided by my answer gave me 9.87 Newton over meter. And voila. This is it, guys. Topic is easy. Just use the equation that you needed and practice isolation, because you know in the exam probably if I let you use an equation, will be the main equation. So you need to practice isolation. And that's it, guys. Have fun. Thank you for watching.